Alrighty, so we talked about this in the notes yesterday. We got identify vertical and horizontal asymptotes, and then we're going to check it by looking at the graph. Because trust me, you don't really want to stick to the graph because the graph is going to be really hard to see the exact values. There's not a great way to do it, but it is really nice to just visually see if your answer makes sense. All right, so vertical, horizontal asymptotes. The vertical asymptotes come from the zeros of your denominator. So if you can get that denominator in factored form, which we should be able to, so it looks like we can pull an x out of everything. Once we pull that x out, you'd have x squared plus 3x minus 18. And then that can even factor further. I don't have a lot of space here, but I'm going to make it work. So we'd have the x. And then it looks like we could use 6 and negative 3 to get the b value. So if we go 6, we go negative 3. Okay, cool. So in this case, we'd be looking at this and we'd be thinking those three values are going to give us our asymptotes. We're going to have vertical asymptotes at x equals 0, x equals negative 6, x equals 3. So it looks like we have three vertical asymptotes. Cool. And then the other piece here with the horizontal asymptotes, those are going to come from looking at the degrees here. Now, in our case, we have a higher degree in the denominator. And so if we look back at our cases, I'll kind of give you the refresher here on this. So case one is what we have. We have higher degree in the denominator. That's going to give us horizontal asymptote at y equals 0. So we can I'm going to go ahead and write that down because that's what it's going to be. And then remember, if the numerator has the higher degree, there's no asymptote. And if the two degrees are equal, that's when you need to do your long division to figure out the shift. So those are kind of your three things that happen. I always remember it this way. To me, this is a typical rational function where the bottom part is bigger. So you're going to have, it's going to create an asymptote because this part's larger. Here, the numerator is larger, so you're not going to get an asymptote. And then if they're the same, it's going to be just an asymptote shift up or down one way, depending on how things work out. So those are your three cases that you want to look at there. All right, so we've answered the question. Let's go ahead and graph this and see if we agree with what we have. Okay, so I went ahead and I typed it in. And so if you're typing this in your calculator, you do need to make sure you put the numerator and denominator in parentheses. So I got my numerator, my denominator, both in parentheses, being divided by each other. And then I graph it, and I just want to look and see if these asymptotes make sense. So I said I should have so the horizontal asymptote at 0, that's definitely going on. You can see these are all leveling off at 0. So that's perfectly good. Check, makes sense. Vertical asymptotes at 0, we see, yep, these are approaching 0, so that one's good. At negative 6, yep, that one's good. But at 3, we don't have that kind of thing going on here. So you might wonder why. Like, why isn't that asymptote showing up there? If we jump over to the table, we do see that it has an error at 3, but then it kind of keeps going and keeps leveling off. So in this case, we actually get, instead of an asymptote, we get what we call a hole. And we haven't really got into this yet, because in this case, the graph isn't like approaching 3. What it means, it just doesn't exist at 3. There's just an open dot there. There's a spot where it doesn't work. And you might wonder, like, well, why were those asymptotes and why is that one a hole? I'll show you. We're going to get into this a little further in the future, but if you're curious, if you factor this top part, this would factor to x minus 3 and x plus 2. And what you would notice here is you have an x minus 3 on the top and the bottom, and those actually eliminate each other. And this is going to cause that little phenomenon that we have called a hole, where you still can't put 3 into this function, but it doesn't have the same asymptote because it doesn't exist really in the function. It's a little weird, just kind of an introduction to it. Again, not something we're going to fully hit, or we haven't really talked about it yet, but it is a thing. So we'll see more of it in the future.